1.4. Okay, 1.4. Continuity and one-sided limits. Continuity and one-sided limits. So in this first chapter, there's a lot of theorems and there's a lot of theoretical thinking. So you need to kind of be able to think outside the box and logically reason a lot of things. So this is the section that has a lot of those. You have to think a lot. Okay, so let's look at this question or this graph here. First question, what is the function going to, or where is the function going to as x approaches 2 from the left? From the left. So basically, where is the function going to as x is going to 2 from the left? -2. Okay, so going to 2 from the left is you look at the left-hand side part of the function. So the function is going to -2. Okay, next. Where is the function going to as x approaches 2 from the right? 0. So from the right is 0. Okay, so limit as x goes to 2 from the positive side or from the right-hand side, the function is going to 0. So where is the function going to as x approaches 2? Does not exist. Yeah, so we talked about this. If both sides are not going to the same number on that x value, then it does not exist. So limit as x goes to 2, f of x does not exist. Okay, let's review your left-hand and right-hand limits. So left-hand limit is basically saying limit as x goes to c from the left-hand side. Left-hand side, we put a little negative sign there. F of x is equal to L. So basically, when x is going to c from the left-hand side, y is going to L. And then right-handed limit is limit as x goes to c from the positive side, f of x is going to L. So it's just kind of re-explaining what left-handed and right-handed limits are. Now this next part is the very important part. This you gotta memorize. The limit theorem. The limit theorem says the limit of f of x as x approaches c is L if and only if. Okay, if and only if statements in math is a very, very strict requirement, and usually when a lot of college textbooks, if they write if and only if, they will write IFF. It means if and only if. So if and only if is not just if this happens, it's if and only if. So this is, this has to happen in order for that statement to be true. So the limit as x goes to c is L if and only if this happens. And what happens? Does not have to do with continuity. Yeah, the left-hand side and right-hand side limits are equal. Okay, you can only have a limit if and only if left-hand side, right-hand side go to the same number. Yes, I've been kind of saying that over and over and over again, but pretty much in this section, we're going to prove that. So anytime you want to tell me that limit is 2, I'm going to say, how do you know? Did you prove the left-hand side? Did you prove the right-hand side? Did you show that it's the same? You have to do that in order to say the limit is that number. Yes?
When they're approaching the same point, but the point is somewhere else.
What do you mean?
Like if it's a whole
but it's still one of the one.
As long as they're going to the same number, that point doesn't have to exist. Is that your question?
Yes. Like in the warm-up, how for number 5, it was like 1.7 if x equals -4, but
Yeah.
Oh, okay, yeah. We'll look at a lot of those questions together. Yeah, so we'll look at a lot of those questions. Okay, let's do some questions, and that should clear up all the confusion. Let's look at this question. So go ahead and write this down. These are classic examples. So f of x is equal to x squared if x is less than 1. It's equal to negative x plus 2 if x is greater than or equal to 1. Find the limit as x goes to 1. So you cannot use a graphing calculator and say, I found it. You have to prove by your limit theorem. Remember, your limit theorem says the limit as x goes to that number is whatever limit it is if both sides go to the same number. Therefore, if we want to prove, or we want to show what limit as x goes to 1 is, we need to figure out what's going on from both sides of 1. So therefore, we need to find limit as x goes to 1 from the negative side. If x is going to 1 from the negative side, which function do I use? Top one, x squared, because that's x less than 1. So that's going to be 1. You just plug it in, right? Because it's continuous at 1. Just plug it in. Okay, limit as x goes to 1 from the positive side, we know we use which one? The second one. Bottom one. And what's that number? 1. Therefore, the limit is 1. Therefore, limit as x goes to 1 of f of x is 1. So this is how you prove. You prove the left-hand side, right-hand side goes to the same number. Therefore, that limit is that number. Okay, this one, you did it on the warm-up, but we need to prove it algebraically. So you have the absolute value of x over x. Show that the limit does not exist at 0. All right, what do we need to do to show the limit as x goes to 0? Left-hand side, right-hand side of 0. So limit as x goes to 0 from the left-hand side. This is a little bit tricky. If you put in 0, what are you going to get?
0.
Undefined, 0 over 0, right? So we're going to be a little bit tricky here and then just actually plug in a number. Whenever you cannot figure out what that limit is because it's 0 over 0 and you cannot use any kind of tricks that we know to solve, you're just going to plug in a number. So what's a number that's a little bit smaller than 0? Oh, a little bit smaller, not a lot smaller. Negative 0.1. We want to be just a little bit smaller, just in case something happens, because we are trying to get really close to 0. Negative 1 is too far. Okay, absolute value of negative 0.1 is what? 0.1 over negative 0.1. What is that? Negative 1. Okay, limit as x goes to 0 from the positive side. All right, if we plug it in, we're still going to get 0 over 0, which is a problem. So let's pick a number that's slightly bigger than 0. 0.1, perfect. So 0.1, absolute value of that over 0.1, that is 0.1 over 0.1, which is 1. So are they going to the same number? No. Therefore, what? Does not exist. Therefore, limit as x goes to 0 of f of x does not exist. Okay, let's try another one. Oops. Let's try this one. Let's have you figure out if the limit exists and what that number is. You guys are really smart, so you can already tell what the limit is, but that's not the point. The point is that you have to be able to prove it. So limit as x goes to 4 negative, f of x is equal to 0. Limit as x goes to 4 positive, f of x equals 0. Therefore, limit as x goes to 4, f of x is 0.
You heard all that therefore stuff?
Yes.
You have to write therefore?
You don't have to write therefore. But you have to write left hand side, right hand side, and then that. Yes, George first.
So is 0 the answer, or is the whole thing limit?
The whole thing is the answer.
whole thing is the-
Yes, correct.
So does that mean we have to write that whole thing on the quiz tomorrow?
If it asks you. So,
Not that much.
okay, so tomorrow on the quiz, no, you don't have to write it out. It's going to be like this. So there's just a lot of limits, and I just want you to solve it. You don't have to prove it. But whenever,
So if it asks you to do it?
right, then you have to do it. Okay, so let's have you do this question really quickly. So you have piecewise function with 5 functions. You have to find all the limits, but don't write out any theorems or proofs. Just write the number, if the number exists. So we are going to do the second one first. Limit as x goes to 1 of f of x. Does not exist. Okay, goes to 1 from the left-hand side, you get 0. Goes to 1 from the right-hand side, you get 1. They're not the same number, so it does not exist. Okay? Okay, next one. Limit as x goes to 2 of the function. 1. Okay, goes to 2 on the left, goes to 2 on the right. We skip that x equals 2. That's irrelevant.
I didn't even see that part. Oh shoot. Okay.
Okay, so skip the part that's x equals to 2. That's irrelevant. It's not coming from any side. Okay, third one. Limit as x goes to 3. 2. Okay, let's do the last two. Those two are a little bit tricky. Limit as x goes to 0.
I would say 1.
Okay, so this is a tricky question because we don't have another side. We don't know what's going on the other side, so we can't, we don't know. If at the best you have to write a plus sign there to tell them that I'm not sure, but I can tell you when you go from the positive side, it's 1. Okay, so this is a little bit tricky. To be a limit, you have to come from both sides. There is no other side. Yeah.
Oh, so then you have
We don't know. We don't have enough information to know what the limit is.
So we just leave that blank on the right.
On the test, it's not going to be this tricky, but you just need to know that you cannot just say there is a limit because I found a number. There is nothing on the other side. You cannot prove where the limit is. Therefore, this one is x goes to 4 from the negative side. F of x is equal to 1. Okay, next, we are going to do a very quick activity. So let's have you take out the whiteboard that's underneath your desk with a marker. The first thing I want you to do is I want you to write what does it mean for a function to be continuous. Write your best definition. What does it mean for a function to be continuous? Write it down and show me your answer. What does it mean when I say something is continuous? Okay. 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 That's probably the best answer in words.
Always continue. Like, it's just like.
Okay, very good. That's what I said last year. Nobody wrote it. That's so sad.
Right here now.
I wasn't in your class last year. It's not fair.
What? No. Okay, very good.
Yeah.
Okay, all right. Let's kind of. I'm not going to disprove your answers, but most of your answers are not. I can disprove it with a discontinuity. So your answers are not good enough to describe a discontinuity. So a lot of you wrote something like no holes. Well, it could be a jump. It could be an infinite, right? Or some of you says can be a line. Yeah, there's tons of things with lines that's not continuous. Or some of you wrote what? I forgot what else you wrote. But those are not great definition of continuity. So let's go ahead and do some exercise. Okay, I want you to draw 2 ways for the a function to not be continuous at 4. So draw 2 graphs, but there are different ways for the function to be discontinuous at 4. 2 ways for this function to be discontinuous at 4. Okay. Don't erase the graph. Okay, good. Don't erase the graph. We're going to need it. Okay, very good. Very good, very good, very good. 2 ways. Very good, very good, very good. Keep the graph, okay? Very good. That's not even a function. Very good. Very good. 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 2 functions. 2 graphs. Okay.
Michelle, would this count?
Can you
Does that count as like
can you actually have an XY axis on yours? Okay, good.
I don't believe in
Good.
extra access.
Uh,
Like that.
okay, keep the graphs there. Keep your graphs there. You are going to draw 1 way to make your graph continuous. Keep it there. How can you make it continuous?
Like,
How can you make it continuous?
huh?
You tell me. How do you make it continuous?
Here. Oh, wait a minute.
How do you make it continuous?
That's not a function.
Okay.
What do you mean?
Wow, that's an interesting graph.
Next to it. Oh, wait, or I can do this.
All right. So, okay. Interesting ways that you guys use to make it continuous. Now, let's erase the graphs. You're going to draw a function.
Wait, can you explain how we're supposed to do it? How are we supposed to make it continuous?
I will show you later. Okay, you're going to erase the graphs. You're going to now draw a function with a removable discontinuity at 4, 3. Draw a removable discontinuity at 4, 3. Removable discontinuity at 4, 3. Okay, very good.
Can we use
Good.
regular terms?
A hole. A hole at 4, 3.
In other words, a
Okay,
hole.
good. Just a hole. Yeah, sorry, that was your label.
Do you want us to remove this?
Don't erase it. Don't erase it.
Yeah.
Okay, good, good,
Yeah.
good. I need X, Y, and I. Good, 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 good. Okay, very good. Good. All right, keep the graphs. Keep the graphs on there.
This is really big.
Can you describe this discontinuity with limit statement?
Yes.
Sure, why not?
Yes.
Write your limit statement. Good. 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 Oh, you guys are excellent. Good. Good. Good.
Also pretty good at math.
Good. Good. Okay, you guys are excellent. You guys wrote limit as x goes to 4 of f of x is equal to 3. Good. Now let me ask you one more question. Don't erase yet. If you want to make this graph continuous, what would you have to do? Fill in the hole. Fill in the hole. Okay, now, therefore, can you write a definition using limit statement to describe a function that is continuous at that point? In order for you to have something that is continuous, what does it have to look like in terms of limit? That just proves that there's a limit. You said it. Fill in the hole. Therefore, in order for that to be continuous, first of all, it has to have, maybe it might have a hole. Maybe it might have a hole at A, right? In order for it to work, that has to have a number there. So, does that make sense?
No.
Okay, so first of all, you told me that on your graph there's a hole at 4. That number is 3. If you want it to actually be a continuous point at that point, then it has to have a point there,
So just do that?
right? No, so basically,
You plug it in
when I asked you to draw a lot of discontinuous graphs, you drew all kinds of graphs. You had one with holes, you had infinite, you had jump. Which is the only one you can make continuous?
there.
The one that only has a hole, right? The one that goes like this, like a jump, you cannot make it continuous. The one that goes like this, the infinite, you cannot make it continuous. The only one that you can make continuous is the one that only has a hole. How do you make it continuous? Fill in that hole. Therefore, for something to be continuous, the limit has to equal that number. Okay? So, this is the big idea. Continuity. The continuity condition. How do you prove that something is continuous at a point? So a function is continuous at c. C meaning x equals to c. So how do you know if the function is continuous at c? When these three conditions are met. Yes. Okay. So how do you know a function is continuous at a point c? When these three conditions are met. Number one, f of c is defined. Okay, that means you actually have a point at f of c. There's actually a number. There's not a hole, there's a number. Second, the limit as x goes to c of f of x exists. Exists means that it cannot be infinite. Infinite does not exist, right? So that's no limit. So it actually has to go to some kind of number. There is a limit. The third one is that this limit is equal to, x, is equal to the actual number. They actually mean the same number.
Oh.
Right? So how do you prove that something is continuous? First, there's a point. Second, there's a limit. Third, the limit and the point are the same number.
You need all three for this.
At every single point or something?
Whatever the point you want to prove is continuous. Now, we are not time to go yet. So this is I guess this is one important thing. How do you prove that limit exists?
Plug it in. Plug it in.
Not just
Use your magic trick.
Yes, left-hand side equals right-hand side.
Oh.
So, if you want to prove that something is continuous and they actually don't tell you the limit, you want to use the limit, you better prove that both sides go to the same number. So you got to go from the very fundamental to prove all this stuff in order to prove that it is continuous. You cannot go straight and say like, yep, I see it is continuous. That's not a proof. You got to show all three statements. One of them, you have to show that there's a limit by both sides going to the same number.
What's
Yes.
this for? We're trying to figure out if there's
Up point.
It's continuous. Is it continuous at that point? That's the question.
at that point.
At a random point.
Yeah.
But there's a graph.